Hello, in this video we're going to talk about factoring using the difference of squares method. Before we get there, I want you to expand the following expressions. You can pause the video and try and figure out what it comes up to, but essentially when I say expand, I want you to FOIL. And you might take the long way out and do the foiling method the way you're supposed to. But once you do it and you line these guys up on top of each other, you should notice that something pretty cool happens. You should first of all note that the binomials, meaning the two terms in each bracket, are conjugates. What does it mean to be a conjugate? Conjugates are binomials that are identical, and you can tell all of these guys are identical. The only difference is one has a plus sign and one has a minus sign in between them, and that happens to be quite useful in mathematics. So that's what a conjugate is. When I go up and FOIL each one, this is what I should get for each expression. You can pause the video and convince yourself that that is the case. In each one of the cases, the two middle terms, the minus 3x plus 3x, minus 2x plus 2x, and minus 5x plus 2x, well, it cancels out. Isn't that amazing? So out of this four-term expression, when I expand it, I am left with just the first term and the last term. And that ends up being x squared minus 9, x squared minus 4, and x squared minus 25. So when I expand, I could have actually used a shortcut and literally just went to the final answer, meaning I would have had to square the first term and the second term and remember to put a minus between them. And that would have been my expansion. Now, factoring is essentially the opposite of that. So the difference of squares method actually really requires you to notice that what you're given is in fact a difference of squares. Difference implies that there's subtraction. Squares means that each term can be represented or is a perfect square, meaning that I can take a square root and get a nice number out. And you should notice that that is the case. So unless you know what difference of squares is, you just won't be able to do it. So it's an extremely powerful method of factoring, but you do have to know it. I should let you know that sum of squares does not exist. So if you have a sum of squares, meaning I have a plus in between two perfect squares, does not exist. There's no such thing. So we cannot factor x squared plus 9. But x squared minus 9, it's good to go. If I try and practice this, x squared minus 25, try and think about it. What two terms go in? Again, they will be conjugates. One bracket will be a plus, the other one will be a minus. And all you really have to do is find the square root of the first term, x squared. So if I take a square root of x squared, I really just come up with x. And step 2 is really find the square root of the second term. In this case, it's 25. Square root of 25 is 5. And all I have to do is place those answers into my bracket. So I end up with x plus 5 and x minus 5, and you're done. You're all done. You might think some of these are difficult, but they're not. You can easily take a square root of each. The first one should be pretty straightforward, x plus 3, x minus 3. The second one, you've got to take a square root of the entire first term, meaning you've got to take a square root of 4 as well as the square root of x squared, and then a square root of 16. You should come up with 2x plus 4, 2x minus 4. The third one will be 9x squared minus 4. Square root of 9x squared is 3x. And then square root of 4 is 2. So we got 3x plus 2 and 3x minus 2. The next one, x plus y, x minus y. Next, x to the exponent 4. If I take a square root of that, I'll get x squared. And then I also have to take a square root of 81y squared, which is 9y. The very last one might seem tricky, but it's not. All you got to do is take a square root of x4, which we've done just in the previous example. And then if I take a square root of 1 out of 9, well, that's actually the same thing as writing square root of 1 over square root of 9. And that turns out to be a really cool fraction, just 1 out of 3. So nothing to it. X squared plus 1/3 and x squared